Hello everyone, thank you for joining in for yet another session, and in this session let's learn about variable length subnet masking. So what is a variable length subnet masking? So in this variable length subnet masking, we are going to perform a subnetting over a given subnet. So why do we do that? We do that in order to have a different subnet sizes. Why do we need different subnet sizes? We need the different subnet sizes because it will help us to avoid or reduce the wastage of a large number of IP addresses. If I need only 30 IP addresses, and if I subnet and my subnet has 128, then what will happen? Then I will have a lot of IP address wastage. So in order to avoid or reduce the IP address wastage, variable length subnet masking provides the solution or gives the solution. And it gives or it rises with an opportunity to reserve subnet for future use. So to make this topic easy to understand, let's take an example, and through the example we'll work it out and we'll try to understand what is variable length subnet masking. Okay, so let's say we are given a subnet of an IP address 192.16800.128/25, and then there is a condition here. It says that we have to provide only enough addresses to cater the number of hosts or nodes or users or the devices that is connected to the network or in this given network topology. All right, so we are aiming to provide only the required possible IP addresses for each of the subnet or each of the network to avoid or to reduce the wastage. I'll say, okay, so to do that, we have to understand what and how variable length subnet masking works. Okay, so what we do is, remember, keep the points of variable subnet mask in mind. We are going to perform a subnetting of a given subnet. So we are subnetting a subnet. So we will subnet the subnet until we feel that an optimized subnet has reached to provide the required IP addresses to reduce the or to avoid the wastage of IP addresses. Okay, so let's take this example here. Here is a given network. So let's find out how many separate individual networks or individual network partitions are available in this given big network. So how many routers do we have? We have two routers here, router 0 and router 1, and it's connected to a switch. So this is one small network, all right? So whatever we broadcast will be circulated in this area, okay, in this area. So we call it network 0. So we have one network, and another one here is a switch, and there are machines connected like local area network, okay, connected to this router. So that is a second network, like let me call it network 1. And then we have another one that is connected. There's a server connecting to this router, and that is another one network. Remember, router divides or partitions the network, or router is the one that helps to relay or helps to transfer information from one network to another network. So remember, router is the one that divides or partitions the network. So it's easy to know how many networks are available by looking into the router and the number of ports connected to the router. Okay, so this is the second network that is connected to this router through this port. All right, and sorry, the third network, and the fourth one is here. So router connecting to this router. So if you look here, the network 0, there are 60 computers in here, and for network 1 there are 25 computers, and for network 2, that is the third network, there are only 2 IP addresses required, one here and one here for this device. So only 2 here, one here, and one here. So only 2. So this network and net 2 and net 3, they require only 2 IP addresses. They require only 2 IP addresses. And for this network, net 1, we require 25 IP addresses. And likewise for net 0, we need 60 machine, meaning 60 IP addresses. Okay, in this given example. All right, so here is a given here. So how many network do we have? we have four small networks. Four small networks. So the IP address provided is 192.168.128/25. So if that is the given IP address or a subnet that is provided or a primary IP address, we are going to perform a subnet over this given subnet. Okay, so let's perform a subnet over this given subnet. So that was the original. This was the original 192.168.128/25. So what does this mean? What does this /25 mean? /25 means the first 25 bits of the 32 bits IP is for the network. Okay, and that helps us to understand how many bits are for the network and how many bits are for the host. And that helps us to understand what is the corresponding subnet mask to determine the network ID. Okay, or the network address. So if you look here, let's say in this given original primary IP address 192.168.128/25, we know that the network portion is 25 bits. So what does that mean? It means out of 32, I have 25 bits for the network. So the remaining 7 bits, that's the number of bits reserved for the host. So in this given network, how many computers can be connected? They can be 2 to the power 7. So 128 IP addresses are available. So how many of them are usable? So the usable ones are 128 minus 2. So 2 to the power n is the number of hosts, minus 2. That will give the number of usable IP addresses. Why did we do minus 2? Because the first one is the network address and the last one is the broadcast address for this given network. Yeah? Okay, so all right, so that's easier to understand. Okay, so from this given subnet, we are going to do subnet in order to create how many networks? 4 networks. And then we might end up having some unused subnet as well for future use. Okay, that's good. So let's go ahead. So what do I do? In order to accommodate this 60, I have to subnet in such a way that I will get at least 60 machines. This is the already given network. So in this network, in this subnet, let's say how many machines are there? 128. Why? Because 7 bits are reserved for the host. 7 bits are reserved for the host. So 2 to the power 7, 128. All right. So 128 minus 2, 126 usable IP addresses. Okay. So if I want to create a subnet, what do I have to do? I have to borrow bits from the host portion of the network. So what do we do? So the given, okay, the original given network is 111.181.81.81 and then 1. So that makes it 8 plus 8 plus 8 plus 1. That makes it 24 plus 1, 25. So 25 bits from here to here, 25 bits belongs to the network, and the remaining 7 bits belong to the host. So what is the corresponding subnet mask? The subnet mask is 18 means 255, 18 means 255, 18 means 255. What is 1 and 70? 1 and 70 is 128. So the subnet mask is 255.255.255.128. So now we know that that is a subnet mask for this given original network. This is the network address for this given network, for this given subnet ID or the network ID. And then now we know for this primary IP address, there can be a possible of 128 IP addresses because there are 7 bit reserved for the host. So altogether, 126 usable IP addresses are available. So how many IP address do we need for this net 0? We need 60. And then for net 1, we need 25. Net 2, we need 2 IP address and then addresses. And for net 3, we need 2 IP addresses as well. Okay, so we will try to subnet. So when we will try to subnet from this given network in order to make sure that the first network N0, which is the biggest, is suffice or it accommodates. Okay, so to do that, all right. So to do that, we need to borrow bits. Okay, so we need to borrow bits. So how do we borrow bits? So this was the old IP address or the primary IP address or the primary subnet, which was given 192.168.100.128/25. So we need to borrow bit from the host portion in order to create the subnet, or reduce the number of possible IP addresses for a given subnet. Okay, so let's borrow 1 bit. So if we borrow about 1 bit, what will happen is the network portion will be 26 bit. The representation could be /26. So the host portion is now 32 minus 26, that is 6 bit. Yeah, 32 minus 26, that is 6 bit. So 2 to the power 6, so that is 64. If it is 64, let's just subtract 2 IP addresses, one for the network ID and the last one for the broadcast. That will make it 64 minus 2, 62 usable IP addresses. Okay, so we have 2 to the power 6, that is 64 possible IP addresses if we borrow 1 bit from the host and give it to the network and make the network 26 bit. Okay, so if that is the case, that means I'm borrowing 1 bit. So 8 plus 8, 16 plus 8, 24, 25, 26. So where it's highlighted by blue. So, green. So it's 26 bits. So from here, all this blue color. So from here to here, that is 26 bit. So if I borrow 1 bit, if I borrow this bit, now this bit could be in the state of 0, or this bit that I'm borrowing could be in the state of 1. So if it is in the state of 0, that will be one network or subnet. And if it is in the 1, all right, the bit is set to 1, okay, that will be another subnet. So I can create two by borrowing 1 bit. By borrowing 1 bit, I can be in 2 state, in 0-8 state or 1-8 state. So when I'm in 0-8 state, that will be one subnet. 1-8 state, that will be another subnet. Okay, so if I if somebody asks me what is the new subnet mask, then if I borrow 1 additional bit. Earlier it was /25, remember that? Yeah, 255.255.128 was the earlier, because 1 and then 70 was 128. Now if I borrow 2 bits, then what is this 1, 1 and then 6 zeros? That is 192. So my new subnet mask is 255.255.255.192. That is the new subnet mask for /26. For /26, meaning the first 26 bit of the 32 bit is for the network. So if the first 26 bit of the 32 bit is for the network, then my subnet mask is 255.255.255.192. So that is the new subnet mask. All right, so if that is the case, in 0-8 state, 1 subnet, and 1-8 state, another subnet. So I'll form 2 subnets. So when it is 0-8 state, it will be, the network ID will be, or the network address will be 192.168.100.128. All right, why? Because 1 and then 7 zeros, that is 128. All right, so the number of bits for the network is 26. Okay, and then when this bit is set to 1, then it is 1 1 and then 6 zeros. So what number is that? 192. So that is the starting IP address of the next subnet, or the network ID. The network ID is the starting of the subnet subnet's IP. Okay, the first IP of the subnet is the subnet ID. So the next subnet is 192.168.100.192 / now we have 26 bit for the network. Did that make sense? All right. So when it is 0-8 state, then 1 and then 7 zeros, that is 128, and then 1 1 and 6 0, that is 192. So I will have 192.168.100.128 as the network ID, and the second subnet 192.168.100.192, that's the second subnet. So for the first subnet, the first usable IP address will be the next IP, so that means 192.168.100.129. yeah, 128 was the network ID for this subnet 1, so 129, and the last one would be 192.168.100.190. Why? Remember? Yeah, there are only, if I borrowed 1 bit, then I'm left with only 6 bit for the host. 1 2 3 4 5 6, right? That means I will have only 64 possible IP addresses. 64 possible IP addresses. So if I start counting from 128, yeah, then the last one to make it 64 is 191. So that's the broadcast. So the last usable will be one less than the broadcast. So 190. Does it make sense? Okay. So for the next subnet is the same thing. The first host address is the next IP of the network ID. So 192.168.192. If that is the network ID, then 93 is the first host. Okay. And remember, it's only six bits for the host. So 2 to the power 6, 64. So what happened? The last one will be 192.168.100.255, which is for the broadcast. So the usable last host IP address is one less than the broadcast. So 192.168.100.254. So we will be able to allocate this particular subnet, this first subnet, for net 0. Why? Because there are 64 possible IP addresses. If I remove the first, the network ID, and the last broadcast ID, in between, how many are there? There are 62 IP addresses. So if there are 62 IP addresses, it accommodates 60. So that is a good optimized subnet. So I will provide this first subnet for this net 0. All right. And in order to, suppose if I give the next one straight away to him, it has 25 machine. It needs 25 machine, but I'm giving him 62 possible usable IP addresses. That is too much. That's why we have to subnet the already subnetted network. Okay, that's where the variable length subnet masking comes in. So this is already a subnetted network, but we are going to subnet it again so that I optimize the number of IP address that I give so that it reduces the wastage, or it avoids or minimizes the wastage. Okay, or provides or give a scope for future use for other network. So this particular second one, there are 62 usable IP address. That's too much. So I'm going to further, this particular network, I'm going to further subnet it so that I can create a smaller network. Okay, so I'm going to further create a subnet from this given subnet. That means 192.168.196/26. So from this subnet 192.168.100.192/26, I'm going to create a further subnet. So how can I create a further subnet? Remember, I need to borrow bits. So it was /26. Now if I borrow another bit, then it will be /27. So the network is now /27. So if the network is /27, how many bits are remaining for the host? 32 minus 27, that is 5. So 5 means 2 to the power 5, that is 32. So if it is 32, how many possible usable IP addresses? 32 minus 2, that is 30 possible usable IP addresses. So if it is 30 IP addresses which are usable, that will suffice for 25 machine. That will suffice or optimizedly provided for 25 machines. Okay, so we will provide 30 IP addresses for this network net1, which needs 25 IP addresses, by borrowing 1 bit and creating a new subnet, 2 subnet from this already existing subnet 2. Does it make sense? Okay, so like say 27 bits, so 8, 8, 16, 24, 25, 26, 27. So by borrowing 1 more bit, earlier it was 26, now I borrow 1 more bit. So when I borrow 1 additional bit, I can create 2 subnet. I can create 2 subnet from 1 bit, because it can be in 0-edge state or 1-edge state. Does it make sense? All right. So 8 ones 255, 8 ones 255, 8 ones 255. What is 111 and 50? That is 224. So 255.255.255.224, that is the new subnet mask. Okay, for /27. Does it make sense? So in this subnet, or in this network, how many possible IP addresses are there? There will be 32 possible IP address in each of the subnet when it is in 0 state, and another one is a 1-edge state, and then the usable will be 30 each. All right. So 192.168.100.192. So how do we get this 192? So 1 1, and then when this is 0, 1 1, and when this is 0. So 1 1, and then when it's 0-edge state, this is, then that is one subnet, 1, 1, and then this is in one net state, that is the second subnet. All right? So the number of hosts, there are 5 bits. So 2 to the power 5, 32. So 0, 0, 0, 0, 0, that is 1, 0, 0, 0, 0, 1. So as it goes on, 1, 1, 1, 1, 1. So that is the number of possible IP addresses in each of the subnet. All right. So the first one is 192.168.100.192. So how do we get this 192? So 110. Okay, and 0 and 0 and 0 and 0 and 0. So that is 192. Okay, so that is the network address of the first subnet. Okay, when this bit, the 27 bit is 0. So 11 is 11 and 60, that is 192. All right. So if the .192 is the first, if this is the first IP address for this subnet, what is the next IP address? 193. So 193 is the usable first host IP address. And the broadcast is, now you remember, 2 to the power 5, 32. So that ends with 223. 223. Okay, that ends with 223 from 192 to 223. That makes it 30 and 2. So if that is the case, the last usable IP address is 222. Okay, for this subnet. Okay, and we can now assign this subnet to this net 1. Why? It has 32 possible IP address and usable are 30 and I need 25. So that seems to be the most optimized one. So I provide that to this network. Okay, net 1 now got this subnet. Okay, which subnet? 192.168.100.192/27. All right, so this next subnet, so I'm going to further subnet it so that I can reduce and leave subnet, some subnet for future use, and some subnet I will provide and allocate for net 2 and net 3. Okay. All right, so the second one is 192.168.100.224. So how do we get this 224? So if you look at how do we get this network address 224, if you look at this 111 and then 50. So what is 111 and 50? So 111 and 50 is 224. Okay, so that's how we get the next network address. That's the shortcut way of finding. So if that is the network address, then the next second IP address is the first host usable IP address. So 225. All right, and 226, 227, 228, keep going. The last one is 255. Then the last usable IP address is 254. So we are going to subnet this further because this subnet consists of 30 usable IP addresses with 32 possible IP addresses. So 30 usable IP addresses with 32 possible IP addresses. So 30 are usable. So that's too much. That's too much. We need only 2 for this and 2 for this. So I'm going to further subnet this network. Okay. All right. So 192.168.100.224/27. That was the subnet which consists of 30 usable IP addresses. So let's further subnet it. Okay. So so that we can get only required or close to the required number of nodes. So we borrow one more bit. So if we borrow one more bit, the network portion is now /28, meaning the first 28 bit is for the network. So if 8 plus 8, 16, 16 plus 8, 24, 25, 26, 27, and 28. So I borrowed one more bit in order to create 2 subnets. So I borrow how many bit? I borrowed one more bit to create 2 subnets. So this borrowed bit could be 0th state or could be in a 1th state. Okay, so what is the new subnet mask? So the new subnet mask is 255, 255, 255, and what is 1111 and 4 zeros? That is 240. So the new subnet mask is 255.255.255.240. What about the number of hosts that it can have in each of the subnet? Is how many bits? 1, 2, 3, 4. So 2 to the power 4, 16 possible IP addresses, and minus 2, that gives 14 usable IP addresses. Okay, so if I subnet this, by borrowing one more bit, then I will have in each network 14 usable IP addresses. But that is still too much. So by borrowing this one bit, I have created two subnet. So the first subnet is 192.168.100.224. So how do we get this 224? 224 is 111, and then this is 0, 0, 0, 0, 0. That is 224. Okay? And then how do we get this next second subnet? The 111, and this is in one end state. So 1111 and then 4 zeros. That gives 240. Slash 28, meaning the number of bits for the network portion from here to here is 28 bits. Okay? So that is the second subnet. Does it make sense? All right? So we can leave this because it has 14 usable IP addresses. We don't need that many. I can further subdivide. See, we need only 2 and 2. So I can further subnet this subnet and try to create 2 and required or close to 2 and 2 size. Okay, so this particular subnet is too big. So we need to further. Why did I say too big? Because it has 16 possible IP addresses and or 14 usable IP address in each of the subnet. Okay, so this subnet is having 14 usable IP address. That's a lot, okay, comparing to what we need here. So I will reserve this and don't use it. Okay, the first one, this subnet, I don't need it. We'll keep it for future use. And then let's further subnet this one, the second one. All right, let's further subnet. So from where do we subnet? The primary IP address for subnetting for the next one is from this subnet, 192.168.100.240/28. So 192.168.100.240/28. Okay, from this subnet, let's further subnet it. So I borrow one more bit. So from 28, I borrow one bit. That makes it 29. That means the first 29 bit is for the network. So 8 plus 8, 16, 16 plus 8, 24, 25, 26, 27, 28, and I borrow one bit. That makes it 29. So out of 32, if I borrow 29 bits and makes it for the network, then I'm left with only 3 bit for the host. 3 bit for the host means in each of the network or the subnet, I will have 2 to the power 3. That means 8 number of possible IP addresses. So 8 minus 2, 6 usable IP addresses in each of the subnet. And that seems 8 seems still too big for, you know, the number of hosts that I need. I need only 2 each. So even that I can further subnet. But before we do that, let's first find out the subnet for this. So in each subnet, when I have /29, in each subnet I have 8 machines. In each subnet I have 6 usable IP addresses. Okay, so if that is the case, look at this. So 1 1 1 1, and then this is in 0th state. Okay, and 0 0 0 0 0 1 0 0 sorry 0 0 1 0 1 0 0 1 1, keep going, and then 0 1 1 1. So those are the possible IP addresses for when this 29th bit is 0th state. All right, so if that is the case, what is the new subnet mask? So we have not found the new subnet mask. The new subnet mask is 8 1s, so 255, 8 1s, 255, 8 1s, 255. What is 5 1s? 1, 2, 3, 4, 5. 5 1s and 3 0. That is 248. So the new subnet mask is 255.255.255.248. Or we can simply write /29, meaning the first 29 bit of the 32 bit is for the network. All right, so when it is in a 0th state, this borrowed bit, that is one subnet. When it's 1th state, that's another subnet. So how do we find the first network ID? Okay, the 192.168.100 dot. So when it's 1 1 1 1 and 0, and then 0 0 0. So what number is that? 240. And when it is 192.168.100 dot, when it is 1 1 1 1 1, that means 5 1s and 3 zeros, that is 248. 248. So this is the second subnet. So in other words, we can write as /29. We can write as /29, meaning the first 29 bits is for the network. Okay, so considering this, even each of this subnet will have 8 IP addresses. This one 8, this one 8. So even that is too much for this net 2 and net 3. So that's why I can reserve this for future use, this first one, and I can further subdivide or subnet this given subnet. Okay, so let's subnet this further. So which one do we subnet? 192.168.100.1 sorry, 192.168.100.248/29. So 248/29. Let's further subnet this. So network portion, let's borrow 1 bit, that makes it 30. So 32 is the total number of bits, and 32 minus 30, that gives it 2. So 32 minus 30 is 2. So 2 to the power 2 is 4. So I have 4 possible IP addresses. So if there are 4 possible IP addresses, then there are 2 usable IP addresses, because 2 to the power 2 minus 2, that gives it the number of usable IP addresses. So 2 usable IP addresses. Looks like we are hitting what we need. So let's subnet with /30. So if we subnet with /30, so it means that the first 30 bit is for the network. So 8 plus 8 plus 8 plus 1, 2, 3, 4, 5, 6. Right? 24 plus 6, that makes it 30. So the last bit here, when I say the last bit, means this 30th bit. So this one, it could be in a 0-bit state, or it could be in a 1-bit state. So when it is in a 0-bit state, what will happen? This the host will be 00011011. So those are the 4 usable IP addresses. Oh, sorry, 4 possible IP addresses, and the usable one will be 10 and 10 and 01. Okay, or 01 and 10. So those will be the usable IP addresses, because the one that ends with 00 will be the network ID, and 11 will be the broadcast ID. Okay, so when it is in a 0-bit state, so 11111 and 0. So what number is that? That is 248. Okay, 248/30. And when it is 11111 and this one is 1, so that is, so how many? 3 6 ones and 2 0. So that is 252. All right. So we have now 2 subnets, okay, that we created from the earlier subnet 192.168.100.248/29. Okay, in which case there were 8 possible IP addresses in each of the subnet. Now when we subnetted this, okay, which has 8 possible IP addresses, when we subnet, we get 4 in each of the subnet. All right, 4 hosts in each of the subnet, or the usable ones are only 2, because 2 to the power 2 minus 2, that gives it 2. Okay, so this subnet consists of only 4 IP addresses, in which I can use only 2. This one consists of 4 IP addresses, in which I can use only 2. So if you look at this, so 248, so that's the 192.168.100.248, that is the network ID. Then the next IP address is the usable one, so that means 249, yeah. And then 250, and the fourth one, so this is the first, second, third, and the fourth one, 251, that's the broadcast. All right, and the next subnet is 192.168.100.252/30. So for this, the first usable IP address is the next IP address. So 252, so the next one is 253. So that's the usable IP address. And the next usable address is 254. There are only 4, so the last one broadcast, 192.168.100.255. So each of them, this one and this one usable, this one and this one usable, this one broadcast, network ID, network ID. Okay, so if that is the case, we can use the first one for, let's say, net 2, and the next one for net 3. Now let's give a summary of what we have done so far. So the first original primary IP address, subnet IP address that was provided was 192.168.100.128/25. So what does that mean? It means that the first 25 bits were for the network. So when we did that, the subnet mask was 255.255.255.128. All right. So that means in that network there were 128 possible IP addresses for the host portion, right? To the power 7. So that is 128. Okay, so we divided, so we borrowed 1 bit and make it /26. So this new subnet mask is 255.255.255.192, and we created 2 subnet, and we use the first subnet for net 0, which required 60 machines, and then 2 to the power 6, that is 64. That was enough and sufficient. So we provide that this subnet for net 0, and we further subnet this because the next one that we need is 25, and the ones that we have here is 60 and 4. We further subdivided or subnetted by borrowing 1 bit, so /27, and the new subnet mask for that is 255.255.224. So by doing this subnetting, what we get is we get in each of the subnet 32 IP addresses with 30 usable IP addresses for this subnet, and another 30 usable IP addresses for this second subnet. So what we did was we used this first one, okay, so this 2.1 we use for net 1, all right, because we required only 25, and then we have 30 usable IP addresses, and now we are left with this subnet. And this subnet we further subdivided, or we further subnetted, okay, by borrowing 1 more bit, so /28, and then when we borrowed 1 more bit, the new subnet mask was 255.255.255.240, and we created 2 subnet by borrowing 1 bit, and then when we from this given subnet we borrowed 1 bit, and then we created 2 subnet, and then when we borrowed 1 bit, 28/28, so that means I'm left with 4 bit for the host, so 2 to the power 4, that's 16, so 16 possible IP addresses with 14 usable IP addresses in each of the subnet. Even that is too big because I needed for net 2 and net 3, I needed only 2 hosts each. So what I did was I further subnet this 3.2, and I reserved this 3.1, this subnet with 16 possible IP addresses with 14 usable IP address. I reserved it for future use, and this second one I further subnetted. So when I subnetted, what did I do? I borrowed 1 more bit, so /29. So the new subnet mask is 255.255.255.248. That's the new subnet mask. So if that is the new subnet mask, then the host bit is only 3. Remaining host bit 32 minus 29 is 3. So to the power 3, that is 8. So each subnet consists of 8 possible IP addresses with 6 usable IP addresses. So even that is too much for net 2 and net 3 because they require only 2 each. So this one is also reserved for future use, the first one and the second one, which consists of 8 possible IP address, is further subnetted by borrowing 1 more bit, so /30. The corresponding decimal equivalent is 255.255.255.252. And then if we say /30, the first 30 bit of the 32 belongs to the network, so the remaining 32 minus 30, that is 2, belongs to the host portion of the network. So 2 to the power 2, that is 4 possible IP addresses. So usable is 2 to the power 2 minus 2, so that is 4 minus 2, that gives 2 usable IP addresses. So in this subnet there are 2 usable IP addresses, and in the second subnet there are 2 usable IP addresses. So in this subnet we assign to net 2, and in the second subnet we assign to net 3. So that's it for today, and I hope to see you and join you in the next session. Thank you.